looking at is the Library Digital Access System, a fully browser-based application for loading, searching, and analyzing library document data. It implements 7 data structures, all running live in your browser. No server, no installation required. Across the top you can see 7 structure buttons: binary search tree, AVL tree, splay tree, red black tree, treep, skip list, and hash table. Each one has completely different performance characteristics, and you can switch between them at any time. Let's start by loading data. Clicking sample 10K sends 10,000 documents into the active structure. The header updates instantly with the document count and total operations. For the AVL tree, the resulting height is just 14 because AVL trees enforce strict balance after every single insertion, guaranteeing logarithmic height at all times. Now let's perform a search. Typing a document ID and hitting search returns the document, including its title, author, access count, and last access timestamp. The console also reports the search depth, how many nodes were visited, and the exact time in milliseconds. For AVL at 10,000 documents, that's typically around 13 comparisons. Inserting a new document is done through a simple form. Provide an ID, title, and author. The tree immediately reorganizes and reports the updated height. If you try inserting a duplicate ID, the system rejects it with a clear error message. The top K query returns the highest access documents. Entering 5 gives you the 5 most popular items ranked by access count, useful for identifying the most read titles in your catalog. The time range filter retrieves every document accessed within a specific date and time window, using the browser's built-in date picker. Now watch this. Enabling multi-tree load and reloading the dataset sends the exact same 10,000 documents into all 7 structures simultaneously. The output console prints 1 result per structure, each with its own load time and tree height. BST finishes in about 31 milliseconds with height 38. AVL takes longer at 84 milliseconds because of the balancing work, but achieves the minimum height of 14. Hash table under 8 milliseconds and height 1. It's essentially a hash map. Clicking benchmark all extracts 100 document IDs and searches for them across every loaded structure. Results are ranked by average search time. Hash table wins every time, a fraction of a millisecond per query among the ordered structures. AVL and red black are fastest, followed by treep, BST, splay, and skip list. Moving to the analysis tab, you get 8 live graphical panels, all updated automatically after every load or operation. The height chart shows current and maximum heights per structure. The search time chart shows average and maximum latency in milliseconds. The depth chart breaks down how many nodes were visited per search. The rotation chart shows how much balancing work each tree performed during insertions. Red-black tree accumulated over 10,000 rotations after the bulk load, the highest of all balanced trees because its color fixed propagation travels the full path on every insert. The search timeline shows per query latency as a line chart over time. The radar comparison scores each structure across search speed, balance, quality, depth, efficiency, and insert speed, making trade-offs immediately visible at a glance. The comparison tab puts every structure side by side in a single table. You can see theoretical complexity, actual document count, current height, average search depth, total searches, and precise timing, all in one place. Clicking any row instantly switches the active structure, so you can jump directly from comparison to operation. The Dataset tab shows you exactly what was loaded: the source name, total row count, auto-detected column names, and a live 5-row data preview. You can load your own CSV file in any format, comma, semicolon, tab, or pipe separated, and the system automatically detects the delimiter and maps columns by name. No configuration needed. Let's finish with the splay tree, the most unique structure in this system, loading the 60,000 Hotspot dataset and running repeated searches on the same popular documents reveals something remarkable. The splay tree moves recently accessed nodes to the root after every query after a warm-up phase on the popular documents. The search depth drops from 18 all the way down to just 3. That is an 83% reduction in comparisons, and it happens automatically without any configuration. This makes the splay tree uniquely suited for library catalogs where a small set of popular documents gets queried repeatedly. No single structure wins on every dimension. Hash table is fastest for point lookups. ABL provides the tightest height guarantee. Tree balances performance with the least rotation overhead. Splay tree excels under repeated access patterns. This system lets you see all of those trade-offs, live with real data in real time directly in your browser. The Library Digital Access System 7 data structures live benchmarking, graphical analysis, and CSV ingestion, all without leaving your browser.